talk about reciprocal ratios and reading off a vertical axis. So they're two separate subtopics to what we've been doing. I'm hoping that you have a pretty good understanding of unit circle stuff. Otherwise, you need to go back and really make sure you're on top of that. And you'll have some time to ask questions about that as well if you need to over the next couple of lessons, weeks, maybe 4 weeks before the exam, whatever. So reciprocal ratios, reading off the vertical axis. Let's talk about reciprocal ratios first. I'm going to introduce a couple of new things to you. First of all, we have sine theta, and we have cos theta, and we have tan theta. That's nothing new. There are three ratios, but we now also have reciprocal ratios. So we have sine theta is equal to 1 over cosec theta. Cos theta is equal to, I might just zoom in on this a little bit, cos theta is equal to 1 over sec theta, and tan theta is equal to 1 over cot theta. And those reciprocal ratios work in reverse as well. So cosec theta is equal to 1 over sine theta, and sec theta is equal to 1 over cos theta, and cot theta is equal to 1 over tan theta. So these are inverse ratios, and they will help us when we get to our graphing stuff. They'll help us with some of the equations and things like that we might moving forward. Sine, cosec, and tan can be converted into the reciprocal ratios. If you're having trouble remembering them, and it's not a major one, so it shouldn't be a big issue, but I did see this the other day, which is interesting. If you look at the third letter in each of the labels there, you'll notice that cosec's third letter is S for sine, sec's third letter is cos, for C for cos, and cot's third letter is T for tan. That might help you remember them as well. So there's our reciprocal ratios. If you know that, you'll see also that you can do similar rearrangements to what we've done before, and we get very similar unit circle results. So, for example, if I wanted to calculate the value of cosec, say 135 degrees, which I could do in radians as well, well, I would just have to write that down as equaling 1 over sine 135 degrees. So you can do that ratio straight away. And once you've done that ratio, you can just draw yourself a little unit circle with a terrible circle like that. Do your 135 degrees and your 45 degrees there, and recognize that using our positive in the second quadrant. I got that 45 from the 45 here, by the way. And so therefore it's also positive in the first quadrant, so they're equivalent. So this is equal to 1 over sine 45, and that's equal to 1 over root 2, which is equal to root 2. So you can do those same calculations. I don't have to go through too many of those because it's a very, very small extension on the stuff you've already done. It's that one extra step at the start, and then you deal with sine 135 like you always have. Equally, you can develop the exact ratios in the same way, just a reciprocal of those exact ratios. So I'm just going to scoot down now, not hiding everything, but I'll just go to here. So in terms of our exact ratios, sine, you remember, sine of 30 was equal to 1 over 2, and sine of 45 was equal to 1 over root 2, and then sine of 60 was equal to root, so you've completely lost control over there, root 3 over 2, and so if you reciprocate those, you'll get the equivalent, but for cosec. Cosec of 30 is equal to 2, cosec of 45 is equal to root 2, and cosec of 60 is equal to 2 over root 3. Because they're the reciprocals. And so we can get the same with the other reciprocals as well. So I'm not going to write down the cosine ones. Cos goes here, but sec being the opposite to cos, sec of 30 is 2 over root 3. Sec of 45 is also root 2, and sec of 60 is equal to 2. And then we have our tan ones. You can go back and look at your table for those. And if we look at that again, we get tan, the opposite to tan is cot. So that's cot being the inverse function of tan. Cot of 30 is, tan of 30 is 1 on root 3, so cot of 30 is root 3. Cot of 45, tan of 45 is 1, so cot of 45 is 1 over 1, which is 1. And then, that's not cot, sorry, that's cos. And cot of 60 is equal to 1 on root 3. So there's some exact ratios as well. Really? Okay, just remember, just have a read through it, you'll be right. Be fine. So you can do the unit circle stuff and apply it to those exact ratios. You can do the exact, apply it to the reciprocal ratios, but you can also do the exact ratio stuff and apply it to the reciprocal functions as well. So just keep that in mind, and you'll have to practice these skills as a worksheet on Pathmark for that, which I'll show you in a moment. So let's just have a look at, I know I probably need to help some people individually, but, it's not on the worksheet. I might do a harder example a little bit later. I might just do reading off the vertical axis now and introduce that to you, and then we can go ahead and I'll add an example, a harder example a little bit later on. So, reading off the vertical axis as a second part is a pretty poor title for what we're about to do. It pretty much explains what we're about to do, and so it's a bit boring. But the idea is quite nice. So, in terms of when you're told to read off the vertical axis, we're talking about a relationship between cos and sine. The biggest issue we have so far is that we can convert sine of any angle to a sine value in the first quadrant. And we can do cos of any angle to a cos value in the first quadrant. We can also convert tan to something in terms of sine and cos, because tan equals sine over cos. But we have a bit of trouble converting, distinguishing or relating sine and cos. We have a trig identity for that, cos squared plus sine squared equals 1, but it doesn't help us in all cases. And there's a really nice relationship when two numbers add up to 90 degrees that relates sine and cos. I'm going to show you now. So let's build this up. First of all, a slightly nicer unit circle than what I've been drawing above. And a little bit of a reminder, for the third time, of some stuff we did right at the start of this topic. So here's a point, P, X, comma, Y. If I draw a line down here and a line there, and just roll over that line there, you'll remember that this is our angle theta. It's from the positive x-axis. And PXY means that this is Y, and this is X. And hopefully remember that Y is equal to sine of theta, and X is equal to cos of theta, and it's a unit circle, so that length is 1. This is considered reading on horizontal axis. That triangle is on the horizontal axis. So what happens if we flip our understanding and flip our visualization and start to look at it from the vertical axis instead, which some of you have already tried unsuccessfully to do. So what happens if I draw a dotted line along here and create this purple triangle? Now, I hope you'll see that triangle combined with the orange triangle creates a rectangle, and so therefore this side length here is also cos theta, or X, and this side length here is also sine theta, or Y. And this angle, can anybody tell me what that angle is? You'll be famous. 90 minus theta, or pi on 2 minus theta if you're working in radians. So we get an angle there of 90 minus theta, and just for the purpose of this, I'll zoom in a little bit there. 90 minus theta is that angle, so we can actually build up an understanding of the value of cos of 90 minus theta and sine of 90 minus theta. So I'm going to do that over on the side here, and you'll see that if I do, first of all, sine of 90 minus theta, this is equal to opposite over hypotenuse, which in this case is x over 1 So it equals x, which equals cos theta. So sine of 90 minus theta is equal to cos of theta. So now we've got this relationship with two numbers, two angles that add to give 90, we can relate sine and cos of those two angles. And it might mean that if you've got a situation where something's given to you off the vertical axis, you can convert it across to the opposite, sine or cos, get it into the horizontal axis, and then go about your business as usual with the horizontal axis readings. And equivalently, cos of 90 minus theta is equal to y over 1, which is equal to y, which is equal to sine theta, and so we get cos of 90 minus theta is equal to sine theta. Okay, so just on the video, just to say this, there is now some questions I'm going to go through on these two topics to make sure you're happy with them. So the first one I'm going to talk about is cos of 70 times sec of 70 and show you how this can be simplified. So we'll do question C out here. C cos 70 times sec of 70, and hopefully you'll all recognise that cos of 70 is a pretty horrible number. If you put that in your calculator, it comes out irrational. I don't know what it is, but the point here is that you can write that down as cos of 70 times by 1 over cos of 70, because sec is the reciprocal ratio of cos, and now you'll see that cos of 70 and cos of 70 cancel out, leaving you 1. So if you're doing simplifying terms here, you get your cosec, your sec, and your cot ratios, reciprocate them and give them their equivalents, and then you'll find that you can cancel things out. So you need to take those opportunities. J, so this is question 4J, is simplify cot of 3 pi over 2 minus A. So this is a tricky question involving both reciprocal ratios and the reading off a vertical axis. So we're going to have to deal with a couple of things here. And I'm going to have to draw a diagram and really build it out. So I'm going to zoom in on this a little bit over here and look at it. Is it cos or is it cot? So it's cot, and I've written cos. I've done that twice in this video, which is great. Okay, so cot, 3 pi over 2 minus A. Well, let's draw that first of all as, let's find where that 3 pi over 2 is. And 3 pi over 2, if you remember, or recall and have a think about, is down here. 3 pi over 2 is 270 degrees. So assuming that A is an acute angle, 3 pi over 2 minus A is in the third quadrant, and that's our angle A. And so a question I had earlier was, when will we need to use this reading off a vertical axis? This question is set up algebraically to be represented as a value from a vertical axis. But we've only worked with horizontal axis, so we're going to have to make those transformations to be able to get it back to a horizontal axis. The first thing I'm going to do is take it into the first quadrant. So cot, I don't know how to deal with cot. I'm going to write it down instead as 1 over tan 3 pi over 2 minus A. And if that's A there, then you'll notice that this is A here, which means that this angle here is 90 minus A. So I can bring it across to the first quadrant using either 90 minus A, or in fact this question is in radians, so I probably should use pi on 2 minus A, or using that this value here being 90 minus A. You can see it there, it's A away from that vertical axis there, A away from 90 degrees. And I've done it again, radians, pi on 2. Okay, so I'm going to change this to be 1 over tan of pi on 2 minus A. So I'm bringing it into the first quadrant. I have to take a second now, remember, to look at my cast diagram and work out if it's negative or positive. So cast, C-A-S-T, and in my cast diagram I see that tan is positive in the third quadrant and also in the first quadrant, so I can leave it as positive. So I've got my simplification down to 1 over tan pi on 2 minus A. Now, I did reading off the vertical axis a minute ago. I never talked about tan. So that's a little bit of an issue. Now I have to introduce that other trig identity, which says that tan of theta is equal to sine of theta over cos of theta. So remember, we introduced that with the unit circle stuff. It came out naturally. So I'm going to write this down now as 1 over sine pi on 2 minus a over cos pi on 2 minus a. And that was the individual term there. So it's 1 divided by that. When you divide by a fraction, it's the same as multiplying by the reciprocal. So I'm going to multiply that. So I'll have 1 times by the reciprocal, which is cos pi on 2 minus a over sine pi on 2 minus a. And now I can use that reading off the vertical axis, keeping in mind that the rules we set up earlier were in degrees, but that's just 90, and that's just 90. Cos of 90 minus a is equal to sine of a. So this is equal to sine of a, and sine of 90 minus a is equal to cos of a. And then doing one final simplification, it's equal to tan of a, because sine divided by cos is equal to tan. So now that's long-winded, and for some of you, you'll have a crack at that and you'll get stuck somewhere, because that involves pretty much every skill we've done for the last week and a half. But if you can practice, and you have to do this, you have to go back and practice each skill individually, make sure that all of those skills you can do without a problem individually, and then you can come and have a go at some of these questions and try and combine those skills. This type of question is reasonably known now. We will do a lot of them in class. You'll see them on the worksheet, but it's very complex. So it'll be considered one of the harder questions in your exam, but you can practice them and build that skill up, okay? Make sure you know the other stuff first, though. And I'll do one more example for you. Actually, let me just pause this. So I'm going to do question C as well. Here's question C. The video's back on, by the way, just in case you want to know. You're now on it, Caitlin. Okay. C. Tan 180 minus a times by sine of 90 minus a times by sec of 90 minus a equals 1. And the question asks you to show that this is true. So we have to show this is true. Now I'm going to just introduce the idea of showing something to you. So if you're asked to show that something's true, in terms of your communication, it's not really good to work down with an equal sign in the middle of the two sides in terms of proof and show. And particularly because in this case, the right-hand side is so simple. So I would be just taking the left-hand side and working on the left-hand side, and hopefully I'll go down and down and down and down, and I'll get to 1. That's the intention here. And it's a nicer communication. Rather than working on two things at the same time and coming out with 2 equals 2 or sine x equals sine x, work on one thing, simplify as much as possible, then work on the other thing, simplify as much as possible, and hopefully those two things are equivalent, and you can make that statement. That's a good way to work it out. So I'm going to write this down now. So it's just the left-hand side. LHS, left-hand side, equals tan of 180 minus a times sine of 90 minus a times sec of 90 minus a. And I have to deal with them all individually. But the first thing I notice here is that this and this, they're reading off the vertical axis questions. So I can see straight away that I'm going to convert them just using that reading off the vertical axis rule. But this 180 minus a, that's going to require a unit circle. So I'm going to put that one together with a unit circle and then do the rest reading off the vertical axis. So first of all, my unit circle for tan 180 minus a, here's 180. So 180 minus a, because it's minus, will be in this direction. I arbitrarily draw a line where that angle is a, so that's 180 minus a, and therefore this angle is also a, and they're equivalent. And this point is just angle A. I just pop on my cast diagram because I'll need it in a second. And tan of 180 minus a is equal to tan of a in the first quadrant, but tan is negative in the second quadrant, so it's equal to negative tan of a. So I have to just check that cast diagram. Then I multiply that by sine of 90 minus A becomes just cos of A. And then I multiply that by sec of 90 minus A becomes 1 over cos 90 minus A. It's our reciprocal ratio. Keep on simplifying. Negative tan of A times by cos of A over, and cos of 90 minus A is sine of A. So I've just brought that fraction together, the second term and the fraction at the end. I can't combine anything there, but I can write tan of A as sine of A over cos of A times cos of A over sine of A. And then I get this nice cross cancelling, and it equals -1, which is a concern, because it should equal 1. Oh, there's a negative there. Look at that. Is that what you were telling me? So my apologies. I'm just going to change that to a negative, and it works. So now I can cheaply write as required with a smiley face.